In this video, we'll have a look at a couple of examples of how you can use the trigonometric ratios to find missing side lengths in a right angled triangle. So in this first example, we have a right angled triangle where we are given the angle size, which is 27 degrees, one of the side lengths, which is 11 centimeters, and then we have an unknown side length labeled x, which we need to find. So the first step is for us to label each of these sides either opposite, adjacent, or hypotenuse. And it's always good to start and think about where is the angle, because the angle helps us determine each of these sides. So the hypotenuse is always going to be the longest side, and it's the one that's also opposite the right angle. So we're going to label this one H for hypotenuse. Now if we look at the angle, the side length that's exactly opposite, well, we call that one the opposite side, so we'll label that one with an O, and then the side length that's next to, we label that one adjacent, because adjacent is just a fancy word for next to. So now that we've labelled our sides, we can think about which ratio would work best for us. So at the moment we have a hypotenuse and we want to find an adjacent side. So we need to look for a ratio that has both of those. So in our case, we are looking for, or we're going to use, the cosine ratio because it has adjacent and hypotenuse in its formula. So first step is to just substitute each of those values in. So cosine of 27 equals, now adjacent is just x for now, we don't know what it is, and then the hypotenuse is 11. Great. Now the next step is to start rearranging this so that we can get x by itself. So the first step would be to multiply both sides by 11, so we're doing opposite operations, and that way that 11 will cancel out and we'll just be left with x on this side. And then on the other side we have cos 27 multiplied by 11. So at this point we can get our calculator out and we can type this in to see what that gets to, and let's have a look to 2 decimal places. So my calculator is saying 9.8010, so we want this to 2 decimal places, so the next number is a 1, so we can just get rid of those last two numbers. So 9.80 centimeters is the side length x. Here's another very similar example, so you could pause this video and have a go yourself and then check to see if you can follow the steps in the same way. So our first step is to label the sides. So the sides that we're working with, well, there's one that's opposite the angle, so we label this one opposite, and there's one that's next to the angle, we label that one adjacent. This one's the hypotenuse, but we're not working with that side length in this particular question. So we're looking for a ratio that uses adjacent and opposite. So in this case, we're going to use tangent, or the tan ratio. So our first step is to substitute these values in. So tan of 69 equals, so on the top of the fraction we have opposite, so that's x, and the bottom of the fraction we have 38. Our first step is to start rearranging, so we'll multiply both sides by 38, so that's opposite operations. So we're doing the opposite of dividing. So right here we've got x divided by 38, so the opposite of course is to times. And we'll do the same to this side as well. So here we're left with x. On this side we now have tan of 69 multiplied by 38. And then we get our calculator out. Let's have a look at this one to 4 decimal places. So my calculator is saying 98.993384, and we want this to 4 decimal places. So the next number is an 8, so that means that last 3 needs to be rounded up to a 4. So we have 98.9934 meters is the side length x in this particular example. Now this last example is a little bit different. This time we're going to find side length y, and we'll see in a sec that the rearranging of this formula is going to be a little bit different, but most of it's the same. So our first step, just as before, is to label each of the sides. So we have the opposite side to this angle we'll label with an O, the one next to we'll label with an A for adjacent, and then the hypotenuse is the longest side length. So for us, we are working with the adjacent and the hypotenuse. So we need to find a ratio that has adjacent and a hypotenuse with it. So that's cosine. So we will be using this ratio just here. So our first step is to substitute these values in. So this is where things start to get a little bit different. Our unknown value is at the bottom of the fraction rather than the top. So whenever we're simplifying and whenever we're trying to rearrange and we have a fraction, we have to break up this fraction by doing the opposite operation, and that's the bottom of the fraction, because this is saying 38 divided by y. So the opposite of that is 38 multiplied by y. So we have to multiply both sides by y. So we will have cosine of 69 multiplied by y on this side, and then 38 on the other. Now we still need to get y by itself. So what we have here is cosine of 69 multiplied by y. So the opposite of that is to divide both sides by cosine of 69. So then we would have y on its own, and then we would have 38 over cosine of 69. So at this point you would get your calculator out, type this in and see what you get. Let's have a look to 3 decimal places. So my calculator is showing 106.03626, and we want this to 3 decimal places. So the next number is lower than 5, so that means that we can just get rid of the last 2. So the hypotenuse is 106.036 meters in length. So for this particular example here, the only thing that was different was we had an unknown at the bottom of the fraction, and whenever we want to break up a fraction, we must do the opposite operation, which is the bottom, so divide by whatever the denominator is. So it just meant we had an extra step to get cosine of 69 back onto the other side.